Please everybody take seats. Todo el mundo, por favor, siéntese. Vamos a continuar la conferencia con la charla del capitán Salim Alavi, que es el creador del evento, el patrocinador del evento. We will continue the seminar with the presentation of Captain Salim Alavi. Captain Salim Alavi, I have met this guy like, I don't know how long ago, almost 20 years. Huh? Yeah, almost 20 years. A long time ago when we were starting. We were young and with more hair. Captain Salim Alavi, let me talk to, he has been in every aspect of the maritime industry, but believe me, every aspect. He has 53 years of maritime shipping this 53 years maritime shipping industry veteran, and his experience encompasses the full spectrum of the industry. During his professional journey, in addition from being a ship owner and ship operation, ship and cargo surveyor, port captain, maritime casualty investigator, he was director of United Arab Emirates flag and maritime advisor to the chairman of United Arab Emirates Maritime Administration, senior vice president, research and strategic planning at DVV Bank, Rotterdam, Netherlands, logistics and LNG supply consultant with Emirates LNG, Abu Dhabi, executive vice president, Armament Seacam, Houston, regional manager, Northern California, Canada Maritime Agency, San Francisco, general manager, Gulf Marine Services, Geneva. Captain Alavi is visiting lecturer at Maritime Law Faculty of Ankara University in Turkey. Captain Alavi holds an MSc in Maritime Economics and Logistics from Erasmus University in Rotterdam, a PG diploma in Maritime Law from London Met, and a diploma in Maritime Casualty Investigation from Kent University, certificates in International Environmental Law and an Alternative Dispute Resolution, from Geneva. And his journeys continued in pursuit of education. Welcome, Captain Alavi.
Methanol is the marine fuel of today and into the future. Waterfront Shipping, a subsidiary of Methanex, has been operating methanol dual-fuel vessels since 2016. We take pride in our leadership role in advancing this technology and the support it can provide to the shipping industry to transition to clean-burning methanol as a lower-emission fuel. Now, Methanex has demonstrated that bunkering methanol is as safe and simple as bunkering conventional marine fuels. On May 11, 2021, Waterfront Shipping launched the first ever barge-to-ship methanol bunkering operation at the Port of Rotterdam in order to prove the ease of methanol bunkering. The Takaroa Sun participated in this operation, becoming the first methanol-powered ship to be fueled by a standard bunker barge. The barge, Evidence, delivered the methanol. Once alongside, the bunkering process began. First, safety meetings between barge and vessel personnel, as well as terminal and vessel personnel, took place. Procedures for the safe bunkering of methanol as a marine fuel were developed in partnership with Lloyd's Register, the Maritime Classification Society, and the Methanol Institute. Next, the hose was extended by crane, lowered, and connected to the barge manifold to begin the bunkering. Finally, once fueling was complete, the barge's hose was disconnected from the vessel's manifold. Methanol bunkering is safe and simple, using the same standard bunker barges and shoreside infrastructure that conventional marine fuels use. Methanol is safe, cost-effective, and environmentally friendly, as it significantly reduces emissions of sulfur oxides, nitrogen oxides, and particulate matter. As a clean-burning liquid fuel, methanol can also help meet the IMO's 2030 and 2050 goals to reduce greenhouse gas emissions. With minimal modifications, methanol bunkering can use the same established bunkering infrastructure that is available at over 90 major ports, offering a worldwide global methanol bunkering network. Ships and ports around the world can easily adopt methanol as a bunker fuel. Methanol is an innovative, clean-burning alternative energy solution, one that offers a future-proof pathway to a low-carbon future. Methanex, the power of agility.
At Waterfront
Good afternoon, ladies and gentlemen. Sorry, we are running a little behind on our program, but I will talk to you today more on the bunkering side. I will spend more time on the bunkering side, talking about the bunkering, methanol bunkering. What happened here? It's not working?
No, wait. Hello? Yeah? But they cannot listen. Okay. No, here.
Okay, go. Skip.
No, what? I will do it. Don't worry.
Let's skip. Yeah. This is the executive summary of my presentation. But these are the ones we use, right?
Yeah, but it's not working. It's
Okay. This is the executive summary of my presentation. Do not believe in anything simply because you have heard it. Do not believe in anything simply because it's spoken and rumored by many. But after observation and analysis, when you find that anything agrees with reason and is conducive to good and benefit of one and all, then accept it and live up to it. And that's what I believe methanol, that's what I believe the methanol is, and that's why I talk about methanol all the time, and I promote methanol, although I've not been employed by the methanol industry ever in my life. This graph reflects that the shipping emissions is 2.7% for the international shipping and 0.5% for the domestic shippings. But what is important over here is to show that the IMO's the sulfur projections are based on 330 million tons of fuel oil consumption, whereas in the GSIS report of 5,000 GT and above, of 2019 showed 93% of the tonnage, 213 million tons. So I think that the carbon emissions which have been mentioned in the IMO GHG reports needs to be revised because of this fact. As Pavel talked before, that the technological obsolescence is an extremely important part, and methanol as a fuel has the ship owners do not need to go back to the drawing board and do the modification, to plan the modification or do the refinancing or do the things in order to comply with the changes that are happening rapidly. And you don't have to wait for the green methanol to come in before they can do it. The other aspect important for the ship owner's perspective is the investment factor, this investment costs. And with the comparison, the delta between a normal ship using the fossil fuel or the conventional fuel and the methanol, the fuel vessel, is about $3 million, $3 to $4 million, versus approximately $30 million for an LNG vessel of the same type. Methanol bunkering, the three modes which are there, it's truck to ship, and truck to ship bunkering is the most common method in the bunkering methanol at the moment. That has been used to date for vessels other than the methanol tankers. And MV&D on the right-hand side of this slide, I mentioned the vessels which are using this method. I'm going to talk about the numbers later. Then methanol bunkering ship to ship, I just showed you the video. That the goal exercise was to carry out an operational test to ship bunkering. The barge, which is alongside supplying the bunkers, is the normal barge which carries methanol as a fuel, methanol as a commodity, and into upriver in the Maas River in Netherlands. There was no modification done to this in order to supply this fuel to this vessel. So basically the modifications that are required to the existing vessels is very, very, very small. I'm in the process of doing a gap analysis on that. Then we should have that in my next seminar, between what changes will be required in order to convert the existing vessels, because that has got a price impact, which I'm going to talk later. Then the methanol bunkering shore to ship, at the moment, the only Methanex, to best of my knowledge, only Methanex is using, and they're using the existing structure, which is for the normal loading of a methanol on both the ships. So that does not, again, once again, I will repeat, does not require major infrastructure alterations or modifications. Yes, there may be some requirement will be there regarding the safety aspect of it, which is there in the next slide of mine. The methanol main hazards and examples of safeguards during bunkering: the flammability, the elimination or minimization of leakage or spills, toxicity, and corrosivity. So these are the things, these are the four main items which need to be addressed into doing any modifications, and that's not a very expensive stuff to do. Then there's the risk factor, the location-specific individual risk and focus area distances, fire focus, explosion focus, and toxic cloud focus. Now, basically what this means is that there cannot be any activity within this specified distances. So if you look at this table, methanol is at the, let's say, 68 meters. Then at the 400 cubic meter per hour flow and 98 cubic meter per hour flow. Similarly, on the fire focus is 154 meter of distance, which is required for the fire focus safety circle, nothing, no activity there. And for toxic cloud, it's only 34. And compare that to the LNG for fire focus is 448 meters, and explosion focus is 229 meters. So there cannot be any activity within this distance when you are doing these bunkerings. Similarly, the toxic cloud on ammonia, 2,624 meters. So that is a huge difference between what safety circles are required when you're doing the bunkering. So what basically it shows over here is, like the existing fuels, the methanol has got very minimum the requirement of the safety distances. Methanol bunkering reference, I think Larry forgot about this, but fortunately I have it. Methanol bunkering reference, you can download it. The link is down. I'm showing it from Methanol Institute website. And it lists the checklists and preparation, advanced delivery readiness to bunker. It's there. Availability, so Pavel has talked and Jason has spoken about it. It's more than 100 ports in the world. So that basically puts it at that bunkers can be supplied in there with very little investment in the infrastructure. And in very short notices, you don't require a lot of lead time on it. Now we come to the bunkering infrastructure costs. The table on the left-hand corner for bunkering infrastructure for 5,000 cubic meter tanks, methanol investment is $750,000 versus $15 million on LNG. For a 20,000 cubic meter tanks, it's $2.5 million in methanol and $50 million on LNG. Well, you can see the difference. And for fueling trucks, 130,000 versus 620. And for bunkering vessel for 2,500 metric ton, $8 million versus 7,500 cubic meter is $33 million. So that's a huge difference. These prices are a little old. It's for last year. They may have gone up. And on the conversion side, if you convert a 3,000 cubic meter barge, my estimate is $0.5 million to $1 million, depending on the number of tanks you're going to convert. This was mentioned by Pavel, but it's more elaborate that the methanol mole is the same energy and chemical characteristics no matter how it is produced. Completely fungible from gray to blue to green, facilitating the blending, the reduced carbon intensity. So there should be one more color. These colors are not defined anywhere. They are just considered, they're taken in as a standard. But there should be one more, orange, combining the fossil and green fossil, blue or biofossil fuel. What I mean by that is that in order to reduce your carbon footprint, you don't have to wait for the use only green methanol. You can use the gray methanol with the combination with the blue methanol and green methanol and reduce your carbon footprint also. Because the green methanol, you reduce your carbon footprint to near zero. Then there are price variance. It's said all the time because the people talk about that LNG has got an LHV of 50 and methanol has got an LHV of 19.6. So it's 2.1 and then all that things. And the diesel has 35. So it is 2.1. That's on the basis of tonnage. But when you take on the energy value basis, this is the table which prices based on Mumbai prices of April. Methanol is 17% cheaper on the LH on the low sulfur fuel oil basis, and 32% cheaper when it comes to the MDO basis. And these are the 422 prices. We frequently ask questions that why methanol is not so popular. What happens when spill and all that. Most of that is covered by Larry and Jason already. And I will just show you something to be adopted. It takes a number of pieces of puzzle to be in place, such as regulatory framework, which we only got it in November 2021. Engine technologies, which are mature, bunkering infrastructure, which is to be developed, still to be developed, and take up the alternative fuels. And the ArcView is one of the first companies in the methanol ship financing, because they were the one who were involved in the Marie Joan financing with Mar Invest and Methanex. And just what Powell mentioned before, that it's really a major breakthrough when Trafigura has chartered the ship. That's really is going to have an impact, and this thing is going to be, the piece of puzzle is going to fall in place in order to complete this puzzle. But another thing talked about methanol is the corrosion and formaldehyde. Now, this is an extract from MAN. And methanol will burn with a temperature of up to 1300 degrees Celsius, and consequently all methanol moles will be burned. Formaldehyde is generated at a temperature of approximately 400 to 600 degrees Celsius. Since our engines do not have any fuel slip, no formaldehyde is generated in the exhaust system. And moreover, corrosion is not an issue, because the existing environment in the chambers is corrosive already. Now I'm going to talk about LNG, because I see everywhere everyone talk about LNG, and the slides which I shown by Angel, he also mentioned, there was no mention of methanol over there. For some reason, methanol is not there at all, for whatever reasons. But what people do not know and understand, LNG is a good fuel for power generation. But LNG is not the right fuel, in my personal opinion, as a seafarer and a ship owner, for a maritime or for a shipborne use, because of the nature of it. So there are various factors which has got a financial impact. Now I will talk to some about them. LNG bunkering steps. This list, LNG bunker checklist, ship to ship, is 28 pages. And you have to coordinate that with the ships, between the ships and the shore, before you can take the bunker. So the total time frame may be 3 hours, 4 hours before you will be able to start pumping after the vessel has come alongside. Whereas methanol checklist is 3 pages. It's just and it will take only maybe an hour before you start pumping, and same thing happened at the time of disconnection, because the whole system, for LNG, the whole system has to be inerted before you are able to disconnect it. Then again, if it is raining and slightest moisture gets into the LNG system will be choked, and this is a major problem with LNG, if it ever happens, because you have to completely stop and then do anything about that. Now, this is a custody transfer. The custody transfer for LNG versus liquid fuel. Liquid fuel, same as methanol also, this is for fossil fuel. And you can see that the one on the left-hand side is a simple process, which is the fossil fuel, the conventional fuels. And the one on the right-hand side is LNG, and that required a lot of experience and understanding of the issues which are there before you can have that. And the industry standard in the terminals, there is a 1% loss during the custody transfer, but then in practicality, it is 2% loss in the reality. And so there is a loss also during the custody transfer because of the Venturi effect. This is another part. The LNG fuel quality. There are 19 countries where the LNG is originating at the moment, and each location or loading location for LNG has got different characteristics all over. Now, I have highlighted 2, which is in the same country, Arzew in Algeria and Skikda in Algeria. And you can see the composition over here. The C1 is 87.4 versus 91.5. In the end is the methanol, methane number, which is 77.3 for Skikda and 72.3 for Ursu. The variation of methane number between the different origins of LNG is 69.5 to 87.4, which has got a direct impact on the derating of the engines. This is another thing. Risk of delivering off-spec LNG. Because LNG is cryogenic, it is carried at minus 161. The same problem will be there with ammonia also, and same problem will be there with hydrogen also. It's carried at minus 161, there is weathering because of the boil-off. Because of the boil-off, the density changes, the characteristics changes. Once the characteristics changes, the methane number changes, and that has again got an impact on the engine performance. Methane slip is another issue. There are the emissions, because at the moment the LNG is being sold as very clean and less carbon footprint and all that. But this is a photo which was taken on a ship which was alongside, CMA-CGM ship. And you can see the methane emissions, the methanol, the methane, unburned methane which is being emitted from the ship. Then another LNG conversion. The ship, or United Arab ship, was built in 2015 with a notation from DNV of LNG ready ship. Was publicized continuously. Hapag-Lloyd, the new owner of the ship, took the ship for conversion in China in 2019, in September, if I recall correctly. And the ship was in dry dock till April or May of 2020. Took them 9 months nearly, or 8 months. And it costs $35 million for the conversion. If you take the methanol ship, if the parent engine test is there, the conversion will cost you $3 to $4 million. If the parent is not there, please ask Shell, why does he charge $5 million more? He will be speaking after me. Now, another thing about LNG is that with the current situation, geopolitical situation, if the complete ban is imposed on the Russian gas into Europe, there will be 50 million tons of LNG will be required. And to build a project on LNG takes about 4 to 5 years. So the LNG demand, as it is, on the right-hand side, you can see the graph, where the demand and supply gap. And from next year onwards till the middle of, I think, 2026 or something, there will be a huge gap between the supply and demand. And that is going to force the prices of LNG to go up, and probably you will have to need a prescription to buy LNG in the pharmacy. Even the World Bank came out with this report in April 21, which says that LNG has got a short-term role from 2020 to 2030. Please, once again, I will say that I've got nothing against LNG or any other fuel. But as a ship owner, I will not use LNG. I will go for methanol. Now I'm going to talk about a little bit. The density is already covered by Jason, so I'll skip that. The technology readiness levels of various fuels. Diesel is 9, liquefied natural gas 8, 9, and methanol 8 to 9. Whereas the remaining ones, I think it will be around 2020, 2030 by the time they will have some recognition or readiness for the use. Because the ammonia engine, which was done by MAN, has been, a few weeks ago I read somewhere that because of this safety reasons, the project has been delayed and the engine will be ready later than 2025. Now, the production cost for marine fuels, the cheapest is hydrogen, with 136 euro per megawatt hour. And full delivered cost show methanol is the lowest cost option. So summary of alternate fuels, average, all of them are average 3.3, methanol 4 and HFO 4, which is basically mean they're more flexible and more readily available. Batteries are severely limited by density as far as long-haul shipping is concerned. Hydrogen in gas form is also limited, but liquid hydrogen is acceptable as ammonia. Biomethane, biomethanol are much closer to the high densities seen in the fossil fuel solutions. Emissions reductions are greatest for biomethane, green ammonia, green methanol. Hydrogen, however, ammonia has question mark over nitrous oxide emissions, which can potentially increase its global warming potential as a fuel. Methanol, again, most of the things have been covered, so I will skip that because of the time. And thank you very much.
Thank you, Salim. You also answered some of my questions. Our next speaker is also a very good friend, Erwin Vargas. I will say this in Spanish, I prefer. El ingeniero Erwin Vargas, el director técnico de MTCC Latinoamérica, va a hablar sobre la importancia del metanol en la región. El ingeniero Erwin Vargas viene de la náutica, de la escuela náutica. He has more than 20 years experience in the maritime industry, working as a chief engineer on board ships and occupying the position of technical superintendent in shipping companies, national and international. He has studies in postgraduate degree in higher education, postgraduate degree in shipbuilding and naval repair, diploma in tugboat engineer, train-to-trainer course on energy efficiency ship operation organized by the IMO and other technical courses. He's currently a professor in the International Maritime University, once Nautical School, and holds the position of Marine Engineer School Director of the Faculty of Nautical Science and MTCC Latin America Technical Director. Welcome, but just let me find your presentation here. Please. Permiso, ingeniero Vargas. Dale.
Muchas gracias. Thank you for being here. Good day to all. It is a pleasure for me to present it today at the conference of the Decarbonization, the rise of methanol as future proof of marine fuel. On behalf of the International Maritime University of Panama, which is the host institution of the MTCC Latin American and whole MTCC Latin American team, I would like to thank to the organizer for letting us to be a part of this great event. I'm going to present it today, the topic, the rise of methanol as a marine fuel, the future in Latin America and the Caribbean. The information that I will share today include introduction, IMO regulatory aspect, GHG reduction, methanol as marine fuel, regional challenge and opportunities, methanol combustion in marine engines, and training and capacity building. I'm going to give a brief introduction of MTCC Latin America. The MTCC Latin America is one of the 5 specialized centers of the global MTCC network, established by the IMO and funded by the European Union, with intention to promote energy efficiency, cheap operation, and reduce their effect to the environment. We have special issues now when we are talking. It's about the IMO, regulatory aspect, and GHG reduction. In this case, we have to know that 2 to 3% of the global GHG emission coming from the shipping sector. That meaning from 2012 to 2028, their increase are 9.6% in these years. That meaning also 1 billion ton of CO2 coming from the shipping sector. But also we have to know that more than 80% of the volume of international trade in goods is carried by sea. Another thing, we have to thinking about the reduced emission will maintain the same service level. For that reason, the decarbonization of the maritime transport requires adequate policy at global levels. Now, I am going to talk of the regulatory aspects. What we have a instrument for verify what is the implement in the some aspect as MARPOL, SOLAS, STCU Convention, and MLC. In this aspect, we are going to talking about MARPOL, SOLAS, and STCW. Why? Because in the Maritime Safety Committee, in the circular 1621 from December 2022, the Safety Committee gives to us awareness of the increase of use of methanol as a fuel and the current lack of the relevant provision in the AGF code. Now we have this opportunity for the use of methanol on board ships. And what is methanol? What is this? Many of the keynote speakers talking about what is methanol. But we know the methanol now is environmental, is availability, affordable, and proven. This is good, important thinking. We cannot say the methanol is the best option, but it's one of the best, and we have now in the market. For that reason, we have to talking about the key takeaway, the position outlook for methanol marine fuels. Meet the current and future emission regulations. Dual engine technology is proven at the commercial scale. Also, the practical and cost-competitive alternative marine fuels provide a pathway to 2050 decarbonization goals. Now, we are thinking about regional, the channels and opportunity that we have in the region, in Latin America, and we include Caribbean. If you saw that graphic, they show us the ports with available methanol storage capacity in Latin America and Caribbean. Some of these countries in Latin America that we are mentioned, Brazil, Chile, Colombia, Mexico, Peru, Trinidad and Tobago, and also we mentioned Venezuela. That meaning in Latin American country we have this store capacity store. But what is the way to the road and regional sustainable development? We have to thinking about, we have to create that kind of conference or event to create a capacity and competence building. Now we have a student here to know more about what we are in the future. You're gonna be a future engineer on board of ships. You have to know about that before you go on board. That's the reason we have to make a research and development with a close collaboration with the institute. This is good, important thing now. For what reason we need that? To make a strategic industry and partnership. And this going to bring to us a technology and cooperation at all levels, including maritime administration and stakeholders. For what? Created innovation. And this going to bring to us the road to a regional sustainable development. We have to create something in our region. We have to think in a national action plan. And what is national action plan? We have to create policies. Policies locally for each country, what we need in our country, in our region. It is necessary to encourage the Latin America and Caribbean states to develop and submit the voluntary national action plan to address the GHG emission from ships and other related maritime activities that will entail also in ports activity. This will be a milestone to start considering the alternative marine fuels, such as methanol that we are talking about now today. I'm just going to mention something about the methanol in a combustion marine engine, but we have a student for engineer career here. We have many people around the world to listen to us, and we have to know about how we use the methanol in combustion engine. But first of all, I want to say about this report of was published by the Clean Energy Financial Service, Phil Losworth, Longspur Research looks into potential solution for decarbonization in the shipping market worth 105 billion per year. This is a good thing, huh? Okay, across the world, methanol is emerging as a clean, sustainable transportation fuel of the future. Also, several companies working with partners worldwide to promote methanol as a clean, a sustainable fuel. But how we use that fuel in the engine? Okay, many or two of the best engine manufacturers already give to the market that kind of engine to use a methanol. One of them is MAN. Is a MAN energy solution. Is one of the manufacturers who bring to us that kind of methanol. What cycle use? Is a 2-stroke. Yeah. Also, they're going to give to us in the 2024 for 4-stroke engine cycle to use also methanol. And we have to know how they can burn the engine. Well, okay, have to see that in the figure. They use a pilot valve, they use many things. In the future, the next speaker, maybe they can mention about how they use the MAN, how they use the burn the fuel, has gas fuel in the engine. This is normal. We also explain for the student how they can burn the fuel as a gas fuel in the engine. And this is good to thinking about. They can introduce in the 4-stroke diesel engine in the future. But also Wärtsilä is another engine manufacturer. They have a Wärtsilä 32 methanol engine. It's already used a methanol in the engine, in the 4-stroke cycle. And also they use a NOR. What is NOR? It's a nitrogen oxide reducer. It's to reduce the oxide to go to the atmosphere. Some of the solutions that manufacturers give to us to reduce also that nitrogen. But one of the most important things in this presentation that we are talking is about training and capacity building. And what is this? We have already tools. We have already that tools for use to transfer for the future officers. Many of you maybe can work in different kind of ship. Maybe the ship that you are working use gas fuel. But you have to know, you have to take that course because the IMO give to us, to all maritime administration, to all stakeholders, the instrument to use that course for the new generation. And also they give to us the IGF code and AGC code. What? One is for constructions and also one is to carry gas as fuel on ship. The course, IMO model course 713 and 714, one is for ratings, yeah, who was working on the vessel who carried fuel as gas as fuel, and another is for captains and officer level is advanced training course for the based on the AGF course. And we know we have a special opportunity now because I only have 5 minutes, but I am happy because you give me the opportunity to present them today here. This is important to us, to thinking in the future. We have the opportunity now to make a strategic alliance with the different partnerships, with different stakeholders, to bring that opportunity for the future, for the next generation. For that reason, we have to working together in close collaboration and contribution for all parties involved in this session of training and capacity buildings. Thank you, everybody, for that presentation and to be here. Thank you a lot.
Muchas gracias. Muchas gracias, Ingeniero Vargas. Our next speaker is Kaji Abu, the Director Sales of MAN ES Denmark. Mr. Kaji Abu is the Director of New Technologies of Two-Stroke Promotion. He joined MAN V&W Diesel in 1983 after having an education in mechanical engineer and a diploma in sales. In 2013, he was the director of new technology promotion two-stroke engines in Copenhagen. 2010, head of marine and offshore Brazil. He was expat in Rio de Janeiro until 2013. He was the head of two-stroke promotion WWO from 2006 to 2008. Head of Research Center Copenhagen from 2002 to 2006. Senior Manager Engineering. Until 2002, manager in two-stroke marine installation department. And he was also from a group manager in two-stroke marine installation department. Project engineering MAN B&W two-stroke port station division, 1986, and marketing of economics and management from Copenhagen. Oh, you already put it. Thank you. Okay, let's welcome Mr. Kaji Abu. Can you hear me? Hello? No, no el mío, el de él.
He will share his own screen. You don't have to stop.
Oh, wait.
Okay. Yeah.
Pero no lo podemos escuchar. Aquí. Yeah.
Hello, can you hear me now?
Hello, yes, yeah, yes. Now,
But I couldn't unmute. You had to do it for me.
now,
Okay.
it's okay, yes.
Okay, thank you very much. And hello here from Denmark. As in the introduction made, I'm a mechanical engineer and work for MAN Energy Solutions. It has always in my career been the two-stroke engines. And what I want to talk about today is about the methanol engine development, but also how we see the market moving. See, if you look at the maritime industry, I think it's very important to look at how much is actually transported of freight by sea. About 80 to 90% of all the goods. Shipping is responsible for the 3% of global CO2 emission man-made. And out of that, 50% of the global freight are transported by MAN Energy Solution engines. That means we not only as human beings have an interest to have a CO2 reduction, greenhouse gas, and so on, we also have a huge obligation as technology providers. So this is one of the things I would like to show how far we are. If you don't look at the red part here, but just the other small areas in gray here, this is our engine program. We go from 3 megawatt up to 83 megawatt. We talk about application for tankers, bulkers, container vessels, and so on. And we are continuously developing these two-stroke engines. What we have today is we have methane engines, we have ethane engines, methanol, LPG, and we also have an ammonia engine, which will be ready in the end of 2024 and transferred to a vessel. That means to a yard, and the vessel will be built We have had some delay, that is fully correct. It will not change the delivery date, but we have to hurry up, that's for sure. If you look at the methane and the ethane and the methanol and LPG that we have today, some of them, ethane and LPG, is purely sold for carriers, ethane carriers and LPG carriers. And until 2 years ago, almost 2 years ago, it was also the same for methanol, only 23 methanol engines, 50 bore, all of them were sold for methanol carriers. This have changed very much, and that's something I would like to show you also. We actually had the first sea trial with such a methanol engine for methanol carriers in 2016. And then on the way, we have tested water and methanol as a Tier 3 compliant equipment and way of doing that to meet and being compliant with Tier 3. We had, you can say, the G95 and so on based on the AP Møller, but I will come back to that. I know we are limited on time. It has been mentioned also by AP Møller himself here about their first order. And looking at the market and what happens there, it was really a big game changer, because suddenly it was not only ammonia seen as one of the biggest or big fuels for the future. No, methanol came in, and we have seen a lot of interest there opening up because this start of it. So today we see also big companies like CMA, CGM have ordered, COSCO have ordered, big container vessels. We have Cargill orders, so for bulker types and so on. All different type of application. We saw this program before. And one of the things that tells me, being so much, working so much for the two-stroke engine MAN energy solution, when we start up choosing to develop a new bore size. Bore size, this is like here, 95 bore is the biggest one, and the 30 bore, this is 95 centimeter in diameter of the cylinder liner. When we start up, suddenly also to extend that program as we have done for methanol, it is definitely because we see a trend in the market really being interested in this application. And if you look at all the different fuels today, dual fuels, you will see that methane is maybe 36%, fuel oil 35% of these different projects, and methanol is 25%. Really going on and increasing for sure. Here we have the distribution type of vessels and so on. If we look at methanol, these 25%, then you will see container vessels 68%, 20% bulk carriers, tankers 10%, and general cargo 2%. So you see different applications starting up looking for methanol, and actually is recognizing all the you can say major advantages that have already been mentioned here in previous presentations. What do we have? We have the proven efficiency. We use the diesel cycle for the methanol and not the Otto cycle. That means we have the same high efficiency as we have the fuel oil burning engine. That means up to 55% at certain engine loads. That means 55% of the burned energy, you can say, is coming out on the propeller shaft. We are using a low pressure. We boost it up to 600 bar. We use 5% pilot energy fraction based on 5% of the energy used at 100%. We can operate the engine from 10 to 100% load, and that's really have been really a success. And we have 19, I think it's 19 engines now, which is operating on methanol and in service. We have hydraulic accumulators. All what you see here is the add-on to the different cylinders. That's also why we have the possibility to retrofit the electronic control fuel oil burning engines to dual fuel engines, because we add this system to an existing engine. It's not another engine, it's the same engine, just added an extra injection system. Unfortunately, we cannot have multi-fuel engines and so on, but we still have used quite a lot of the same technology with double-wall piping, which is ventilated with detectors for any leakages and so forth. Accumulators, fuel booster pump here, and this is where, as I said, we come in with 13 bar, we boost it up to 600 bar, 500 to 600 bar into the combustion chamber. We also have sealing oils, so in this pump and valve system, we can segregate where the methanol is and also the lube oil, you can say sealing oil. We are, from our side, looking into safety. We are looking very much into the fuel gas supply system, not only of the engine. We have a big cooperation with the classification societies, yards, engine builders, and of course, you can say ship owners and other interest parties like, you can say, fuel gas supply system suppliers. We could, this, as mentioned also already, this, you can say, methanol is a very simple fuel to utilize. It's not cryogenic, and you can split it up in service tank, fuel valve train. You have a ventilation system, you have a low flash point, and you have a purging system. This fuel valve train, which is here just after the pumps and filters and so on, we have the tank here. Then the fuel valve train itself is a very vital part of the control of the engine, because if there is a leakage observed, it will tell this fuel valve train automatically to stop the supply of methanol, and it will also open up for the nitrogen supply, so it will drain the system and you don't have methanol on the engine after that. The engine will still automatically continue on fuel oil, so you're not losing power if you are in a critical situation or not. Not at all. You don't even feel it when you're on board and such a change is made. With regards to lube oil, I'll not go too much in detail, but we recommend to use what we today call the category 2, which also give a very high detergency, even though you have no or very little sulfur in your fuel oil, as you have when you are operating on methanol. It could only come from, you can say, the pilot oil, if there's sulfur in that, and then it will be very low or ultra low sulfur fuel oil. So what we could summarize is large interest for methanol fuel ships. We are, I have to say, and also taken with our trousers down, because the interest for methanol came in. We knew from beginning that would come interest for that, but it came really, really fast after the first A.P. Møller Maersk vessel was ordered. We have more than 150 engines in projects now on methanol. It's mature technology. We know what it's there. It's proven. Service since 2016. It's scalable transition, because if you have a little bit of green in the future, in the transient bridging time and so on, if you have some green methanol, you can blend it in, and you will stepwise you will go for a transition for a lower CO2. Green methanol production picking up. We see huge interest also there for investment and so forth. Thank you very much. I hope you enjoyed, and I will also be here for the questions.
Thank you very much, Mr. Wu. Quiero recordarle a todos que al final van a hacer la sección de preguntas y respuestas y que tendremos un cóctel. Por favor, no se nos vaya. I just want to remind everybody that at the end we will have a session of question and answers, and we have a cocktail. Our next speaker also comes from the engine sector. It's Olmedo Farfán. He's the sales manager from Wärtsilä, North America. With over 18 years of experience in the commercial marine industry, Olmedo Farfán specializes in propulsion integration, engine performance, and decarbonization technology. Olmedo is the North America project sales manager at Wärtsilä. He also has extensive experience in global sales and leadership development across a variety of industries from Fortune 500 companies, shipyards, and private equity firms. In his current role with Wärtsilä, Olmedo leads the decarbonization efforts with marine customers as well as implementation of propulsion solutions for more efficient and profitable customers' operations. Olmedo is a graduate of the University of New Orleans with a degree in naval architecture and marine engineering. He also holds a Master of Science in Mechanical Engineering from Purdue University. Welcome, Olmedo. Let me... Wait. Hey. Yes, that's what I'm trying to do.
Okay.
Yeah.
Ahora sí, ¿me escuchan?
Sí.
Okay. Well, I'll say these few words in English at first because actually the presentation I was asked to do, and first and foremost, thank you, Captain Salim, for the invitation and this opportunity and this really great event. But I made all my presentation and everything in Spanish as I was asked to do. So I will be switching to Spanish in a few seconds. So I apologize for the other colleagues that, that they don't speak Spanish, but I'll go ahead and do that. I will share my screen now, the presentation, if that's okay. Okay. Listo. ¿Me escuchan y pueden ver la presentación?
Perfecto.
Ok, muchas gracias. Bueno, muchas gracias a todos por la oportunidad de poder estar acá y poder compartir un granito de arena en este tema muy importante que es el metanol. Creo que el tiempo de hablar de esto está preciso en relación a que estamos entrando en 2023 y este tema viene muy, muy caliente, la verdad, para el próximo año. Como ya lo dijeron, mi nombre es Olmedo Farfán y yo estoy representando a la empresa Wärtsilä, que pues espero que todos la conozcan, pero para los que no la conocen es una empresa finlandesa que lidera el mercado de marinos y la parte de oil and gas en aplicaciones de alta potencia, ¿no? Hoy día me voy a enfocar un poco en hablarles en lo que Wärtsilä ofrece en relación al metanol. Nosotros como Wärtsilä tenemos todo lo que son kits de conversión para los motores de diésel, convertirlos a metanol. Entonces eso para embarcaciones existentes es muy beneficioso y obviamente estamos ya entrando en el 2023 con motores nuevos que ofrecen el metanol y otros combustibles también para embarcaciones nuevas o repotenciaciones. La disponibilidad en relación a los motores, tenemos por ejemplo hoy día lo que son los kits de conversión para metanol disponibles realmente ya en motor Sulzer ZA40S y está en los motores en sí completos ya con metanol para el W32 comenzando el próximo año, el W20 en el 2024 y el 2046 F y DF para el 2025. En esta presentación me quiero enfocar un poco en el W32 y la razón por eso es porque tenemos más de 2.000 motores W32 instalados alrededor del mundo y estos motores pueden hacer uso de estos kits de conversión que los puede transformar de diésel a metanol. Esta actualización, muy importante, no representa una conversión mayor o un cambio mayor cuando se trata de hablar con las sociedades clasificadoras o con los certificados EIAPP. Entonces, eso es importante. Y la otra cosa importante es que esto no impacta la eficiencia o la entrega de potencia del motor, así también como la respuesta de demanda de carga. Entonces, estas conversiones que hacemos son realmente muy interesantes, ya que le dan la flexibilidad sin usted perder ningún tipo de eficiencia o rendimiento en el motor. Como les comenté, quiero hablarles un poquito más del W32, el Wärtsilä 32, que viene ya listo para trabajar con multicombustibles en el 2023, metanol siendo uno de ellos, pero puede trabajar con LFO, con biocombustibles, con HFO. Y este motor, bueno, para los que tal vez no lo conocen directamente, es un motor que es un motor va en línea o en V, desde 6, 8, 9 cilindros en línea, 12 y 16 cilindros en V. Y está entre 3.5 a 9.3 megawatts de potencia. Se usa en muchas aplicaciones, como diésel eléctrico, como motores auxiliares y obviamente como motor principal de las embarcaciones, ¿no? Les comenté que está disponible a partir de, en realidad, el segundo trimestre del próximo año como un motor completo, pero el kit ya está disponible. El kit para convertir los motores W32 existentes ya está disponible el día de hoy. Acá, rápidamente, unos ejemplos de en dónde este motor W32 está siendo aplicado al día de hoy. Ya les comenté que son más de 2.000 motores que están en el mercado, en ferries, en aplicaciones mercantes, en icebreakers, en todo este tipo de embarcaciones ya tenemos. Si a lo mejor ustedes son usuarios o trabajan con usuarios que ya tienen motores W32, vuelvo y repito, el kit de conversión es una buena opción para alcanzar estos niveles de CO2. Creo que también mi colega anterior lo comentó, cuando los OEMs de motores desarrollamos este tipo de motores con metanol, tratamos de mantener los componentes básicos del motor, los más principales, sin cambiarlos. No estamos cambiando pistones, ni cigüeñales, ni bloques, ni nada de ese tipo de cosas. Entre un motor a diésel y un motor metanol, lo que realmente cambia un poco es el sistema de combustible. Y ya lo van a ver un poquito más en unas gráficas que tengo acá. Pero lo principal que cambia es que el motor a diésel tiene su bomba de diésel, el jerk pump que le llaman, y el otro tiene un sistema de common rail con metanol, más el jerk pump, porque estos motores pueden trabajar entre metanol y diésel sin necesidad tal vez de forma automática, vamos a decirlo así, ¿no? Sin necesidad de que sea algo manual. Se habló mucho en otras presentaciones ahora en la mañana y el día de hoy, muy interesante la verdad, pero muchos de los beneficios que trae el uso de metanol, especialmente desde el punto de vista motor, una reducción de 92% en CO2. Decimos 92% porque siempre hay un poquito de pilot diesel, ¿no? Que tiene que ser usado y hay un poquito de emisiones ahí, pero la reducción es muy, muy buena, 92%. En lo que es otros tipos de emisiones como el NOx, 50%, y al usar metanol obviamente no tenemos nada de sulfuro, de SOx o las partículas matters, ¿no? En cuestión de relación peso-potencia es un motor muy, muy eficaz, ¿no? Obviamente 4 ciclos, motor bien compacto, ya lo dijimos, un motor con multicombustible, tiene bajo consumo de combustible en todo su rango de potencia y obviamente tiene soporte en campo a través de nuestra red global de servicio. ¿Ok? Un tema importante, cuando se están pensando en usar metanol, los tanques de combustible obviamente van a tener que ser actualizados, cambiados o creados. Una de las cosas interesantes vamos a decir, entre marine gas oil o heavy fuel oil, y se lo convierten para metanol, es que ustedes van a necesitar un poco más de volumen de combustible para una misma autonomía. Por ejemplo, acá un ejemplo muy rápido, si se trabajaba con 120 metros cúbicos de volumen, incluido el cofferdam, ahora se va a necesitar aproximadamente un 67% más de volumen, 200 metros cúbicos. La buena noticia es que el metanol, como también ya lo explicaron otros colegas, es un combustible que es más o menos benigno también, ¿no? Entonces, puede ser utilizado el tanque, como se muestra aquí en la figura, el tanque en verde, las planchas exteriores y el tanque de lastre, por ejemplo, todo puede ser utilizado como espacio para combustible, ¿no? Sin ningún peligro de que, bueno, si existe algún accidente, que el combustible vaya a crear un daño enorme al medio ambiente, ¿no? No es lo mismo en el caso, como se muestra en la figura izquierda, el tanque es de diésel, ¿no? Tienen que tener todos estos espacios de protección. Entonces, bueno, hay que tener en consideración eso también. Así, una visión muy rápida, yo sé que estamos con el tiempo, rápidamente voy a decirles en qué consiste esto, y creo que el colega anterior dijo casi lo mismo, ¿no? Entonces se necesita siempre una bomba de baja presión con enfriador, un tren de válvulas de combustible, el metanol pasa por una bomba de alta presión y luego pues va al motor, y tenemos también un sistema de control, de sellado, que utiliza aceite, ¿no? Y siempre se necesita o se recomienda el uso de un generador de nitrógeno para crear una atmósfera inerte, ¿no? Y poder mantener el metanol de manera correcta, ¿no? Y no exista corrosión tampoco de ese tipo de situaciones. Acá básicamente es el mismo esquema, un poco más granular, pero la misma historia. Desde el tanque de metanol, todo tiene que llegar hasta el inyector, que es un inyector obviamente especializado para recibir metanol y diésel, y pasando por los diferentes tipos de bombeo y control de aceite. ¿Okay? Acá, las siguientes figuras, no vamos a entrar en mucho detalle porque sé que estamos con el tiempo, pero en estas siguientes gráficas que les voy a mostrar, cualquier cosa que esté de color, que no sea gris, son los elementos que son parte del kit de conversión, ¿no? En este caso, tenemos la parte de metanol acá, ¿no? Que está en rojo y en fucsia, está el amarillo, el diésel, tenemos el sealing oil, que está en la parte, no sé, medio mostaza, y la parte de control de aceite en azul. Obviamente el inyector va a tener que ser cambiado. Entonces, acá también otra visión un poco general de en qué consiste el kit de conversión. Todos los elementos que están en colores son los que irían a cambiar. En este caso se presenta la parte del metanol, que va de fucsia, de alimentación, y de retorno en la parte roja. En verde están los inyectores, obviamente, y la parte amarilla son parte del sistema de diésel. Otra visión y un poco más, ahora mirando a la parte de aceite, a la parte del control y sellado de aceite, ¿no? Todo se controla automáticamente por un sistema que se llama UNIC, y vuelvo y repito, esto hace parte del sistema del kit de conversión, digámoslo así. Bueno, pero ahora mirando una aplicación un poco más real, perdón, me pasé, quería mover esto de aquí. Se habló un poquito también de esta embarcación llamada la Stena Germánica, parte de la empresa Stena Line, que hicieron una conversión del motor diésel, 4 motores, de hecho, 4 motores convertidos a metanol, que son, como se muestra acá en la foto. Esta primera foto aquí en la mitad era el motor original. La foto de la derecha acá se muestran ya el sistema convertido con las diferentes tuberías, con los diferentes sistemas. Acá una foto del tanque de lastre que fue usado para el combustible, para el metanol. Todos los sistemas de líneas de combustible de metanol, que en este caso, si la memoria no me falla, son como de 10 a 15 metros que tenemos de tubería a lo largo de este ferry, de doble pared, obviamente, con todos los sistemas de seguridad, y los otros sistemas que ya les había mencionado, de bombeo, sistemas de control, ¿no? Esta es una embarcación que sigue exitosamente trabajando con metanol hace más de 7 años. Desde el 2015, esta embarcación ya real, operando en escala obviamente real, viene trabajando sin ningún problema, y es algo que lo utilizamos como un ejemplo a lo que los motores W32 pueden hacer el día de hoy. ¿Okay? Bueno, haciendo un poquito de resumen de lo que dije, todo este sistema de conversión, estos kits de conversión, son una solución muy eficaz para las embarcaciones que están el día de hoy existentes con W32. Siempre vamos a estar haciendo el análisis de ingeniería de todo el proyecto, desde el diseño hasta la implementación, porque está más que claro decir que no es un kit que se saca de la repisa y dice aquí está y sirve para todo. Hay que hacer la ingeniería necesaria para cada embarcación. Y obviamente, a partir del próximo año tenemos ya los motores para sus repotenciaciones que sean necesarias, ¿no? Como les comenté, a partir del segundo trimestre del 2023. Finalmente, y con esto cierro, solo recordarles que, pues sí, Wärtsilä continúa invirtiendo tiempo y horas y dinero en la tecnología, ¿no? Siempre a la vanguardia. Hemos terminado o ya tenemos desarrollado el tema de metanol desde el 2015, con más de 100.000 horas de ingeniería y desarrollo, más de 7 años en operaciones reales, y seguimos trabajando el día de hoy en motores que trabajan con amonia y con hidrógeno. Amonia también estará terminado para, si Dios quiere, finales del próximo año. Ahora mismo, en este año, se está terminando unas pruebas en escala real, y para el 2025 tendremos también motores trabajando con hidrógeno. La misión de nosotros es tener la tecnología disponible antes de los requerimientos ambientales. Bueno, les recuerdo, yo soy el Meo Farfán, y si alguna pregunta tienen, con mucho gusto al final podemos revisarla. Muchas gracias por su tiempo.
Gracias, muchas gracias, Olmedo. Muy interesante.
Gracias a usted.
Nuestro siguiente orador es el profesor Alexis Javier Rodríguez, de aquí de la USMA. El profesor Rodríguez empezó como un marino en viajes internacionales. Obtuvo su diploma en Derecho y Ciencias Políticas de la Universidad de Santa María de la Antigua con honores, magna cum laude. Tiene una maestría en Derecho Marítimo, una maestría en un MBA en puertos, un Environmental Management and Carbon Neutral from Air University, Deusto University Bilbao, y de España, y en conjunto con la Universidad de Santa María de la Antigua, también con honores. Tiene un MBA de la Universidad del INCAE University y un posgrado en Energía Marítima de World Maritime University. El señor Rodríguez es profesor de Derecho Internacional y Convenios Internacionales en la Universidad de Santa María la Antigua. Es también un profesor visitante en la Universidad Sergio Arboleda de Santa Marta, en Colombia. En el sector público trabajó en la AMP como jefe de cumplimiento, del Departamento de Cumplimiento, y también en la Autoridad del Medio Ambiente como director de Cooperación Técnica. Déjame nada más buscar la presentación, que es esta. Ok, los dejo.
Buenas tardes. Bueno, es un poquito más de la historia, que siempre me ha gustado, si estoy en Panamá, hablar en español, así que sorry for all the persons that are online and also here present. So, well, vamos a hacer un breve resumen. Yo sé que estamos overtime, así que esto es como presentaciones después del almuerzo, así que son las suficientes, el cierre o eso. Así que vamos a tratar de hacer un marco conceptual, digamos, bastante rápido de las presentaciones de hoy y dejar esa semilla para el futuro seminario, que por supuesto ya hablé con el profesor Allard para dar una ampliación de esta. Así que yo quería hacer un poco un resumen. Hoy hemos hablado de la parte técnica, de la parte de requerimientos ambientales y justamente de la necesidad de los combustibles limpios. Hoy estamos hablando de metanol y vimos muchas de las ventajas, de las perspectivas y soluciones que existen ya implementadas. Yo creo que parte de lo importante de este ejercicio es ver cómo una tecnología puede ser feasible, rentable, digámoslo en cierto aspecto, pero también contribuir con las metas de descarbonización a nivel global. Una de las partes interesantes cuando hablamos de combustibles y de nuevas tecnologías es la importancia que pueda ser escalable a diferentes sectores. Y yo creo que este es un poco el ejercicio que nos queda hoy. Y disculpen, estoy hablando un poco lento, pero sé que hay traductor, entonces, para no que pierda el hilo. ¿Y por qué lo menciono? Porque cuando entramos o hacemos un análisis histórico de las nuevas tecnologías y los combustibles, es importante resaltar la necesidad que pueda ser transferible no solamente a un sector o a un ámbito particular. Y el que hoy hablamos es el sector marítimo. Y así lo ha mencionado la historia, para no mencionar otros combustibles, pero la historia lo ha dicho, de que justamente debe haber la necesidad de apalancar financieramente el combustible o la fuente de energía con otros tipos de recursos. Y creo muy importante identificar, o vemos hoy, cómo los combustibles limpios, particularmente el metanol, puede ser una de las opciones dentro de esa canasta de opciones que existen en combustibles limpios para que pueda ser transferible a otros sectores, particularmente que tienen una relación con la industria marítima. Porque cuando hablamos de combustibles y ese valor agregado que genera la utilización de un producto cero carbono dentro de la cadena de suministro, entonces involucramos otros sectores como la parte logística, como la parte de la entrega de ese producto, como ese producto sale desde su producción, digamos, desde el campo, hasta la parte final, digamos, que es el cliente que está dispuesto hoy en día, y hoy lo podemos, existe estudio, análisis, o podemos hacer un survey, hoy el cliente está dispuesto a obtener un producto que tenga un valor agregado llamado cero emisiones, que no existía antes ese deseo particular, digamos, o ese interés de pagar adicional por lo que hoy puede ser un poco más costoso, que en el futuro será algo reglamentario. Y de aquí viene la parte importante de ver cómo toda esa cadena se va alineando. Una de las enseñanzas más importantes que nos ha dado el sector marítimo es la reacción a diversas regulaciones internacionales que han venido generando ese cambio. Y creo que en las últimas presentaciones lo hemos visto. Ya nos ha hecho un modelo predictivo, miren esto, de ir pensando en cuáles serán las próximas regulaciones en 10, 15, 20 años y generando los diseños para poder ir cumpliéndolas. Y eso quiere decir, lo han escuchado de los técnicos, que hoy en día no necesariamente es un requerimiento, digamos, global, pero ya para estar preparados mejor vamos pensando en el futuro. Y esto es parte de lo que hoy justamente yo creo me llevo, de la importancia de ver cómo en sectores que no tienen una relación, porque partamos de una premisa, la Organización Marítima Internacional dentro de su ámbito de aplicación es las embarcaciones. El tema portuario, el tema logístico no está dentro de los principios de la Organización Marítima Internacional. Sin embargo, es uno de los que apalanca, digamos, toda esa cadena de suministro. Y aquí viene la importancia de ir, digamos, aterrizándolo ahora a nuestra región, porque al final del día esto es un seminario que se está dando en Latinoamérica con la participación de expositores a nivel internacional. Y es la necesidad de identificar la mayor cantidad de combustibles o fuentes limpias que nos permitan llevar una transición en toda la región y que particularmente no sea un sueño, y esto se los dejo quizás a un punto de vista más didáctico, ver uno de estos buques, una de estas máquinas, simplemente por imágenes, sino verlos en la realidad. Y parte de esa es mi experiencia. No se imaginan la satisfacción cada vez que abordaba un barco o un buque que tuviese una nueva tecnología. ¿Por qué? Porque decíamos, hemos logrado algo, hicimos un cambio, ese buque llegó a nuestra región. Y para eso debemos ir planificando toda la cadena de suministro para que como cualquier otro tipo de combustible limpio, pueda generar ese valor agregado. Yo pongo un ejemplo, y es que generalmente cada vez que voy a consumir un bien o un servicio y me ofrecen un diferencial entre un producto que tenga una baja emisión con un producto que no, escojo el que tenga la baja emisión. Y se los digo, hablando desde el punto de vista económico, la diferencia cuando haces el split o distribuyes el valor de esa, digamos, ese intangible ambiental, realmente el diferencial no es mucho. Y qué bonito será tener un buque con una carga que venga en un buque que utilice este tipo de combustibles, pero que también hasta el delivery de mi casa y que cuando me lo entreguen pueda tener la opción de este tipo de combustibles. Y conversaba con el doctor y le preguntaba, y me decía de la historia del metanol, cómo se utilizó en algunos tiempos, y se los invito a que estudien, porque en verdad me dejó eso intrigado ayer, que estaba investigando un poco más de eso, cómo este tipo de combustibles pueden ser replicados en otras modalidades de transporte. Los compromisos, para cerrar, internacionales, se basan en un paraguas, y el paraguas es el Acuerdo de París. Generalmente la mayor cantidad de la presión que existe en este tipo de regulaciones para que se generen los cambios son iniciativas que nacieron desde los objetivos del milenio, se transformaron hacia los objetivos de desarrollo sostenible y todas las modificaciones desde que se desarrollan en la parte ambiental. Pero cada uno de nuestros sectores o industrias tiene la facilidad de adaptarse en base a sus principios. Y hoy el seminario que hemos tenido la oportunidad nos ha brindado esa fase de conocer una tecnología que no está lejana a nuestra industria ni a la implementación de la misma dentro de nuestro diario vivir. Así que los exhorto justamente a que continuemos realizando este tipo de seminarios, teniendo en cuenta que las tecnologías existen, pero veamos hacia cómo la podemos implementar, generando, lo primero, políticas públicas adecuadas, programas pilotos, pero lo más importante, y quiero felicitarlos porque están aquí, es la formación. Lo conversábamos ayer en esa plática y decía, podemos tener la mejor tecnología, el mejor combustible, pero sin el factor humano o la capacitación adecuada, no vamos a avanzar. Y les pongo un ejemplo y con esto cierro. Puedo tener el vehículo más eficiente, pero justamente si no cambias el mindset o la forma de conducirlo, si no cambian y ustedes no son entrenados con las nuevas tecnologías desde toda la cadena de valor de un producto o combustible limpio, no hemos hecho nada, porque nuestra cultura va a ser acostumbrada al business as usual o al hacer los negocios como siempre. Así que muchas gracias y disculpen, pero uno se adapta en base a las presentaciones y cumplí con el tiempo, doctor Alar.
Gracias, excelente conclusión. Captain Alavi, are you gonna be here for the question and answers?
Yep. Yes.
I have the microphone.
We have here some questions, by the way.
read the Spanish one.
I will read the ones in Spanish, I will translate. They ask, do we have in Panama enough renewable energy available for the production of, I suppose it's methanol? What do we need in concept of incentives and politics and incentive? I don't know who can answer that. Actually, I don't know who can answer that.
Erwin?
Erwin or Alexis?
Bueno, respondiendo a la pregunta, en Panamá, si tenemos suficiente energía renovable disponible. La verdad, no tenemos la suficiente energía renovable, pero ya se hizo un trabajo con el World Bank, donde se mandó una especie de informe sobre las posibles políticas para la creación de Plan de Acción Nacional, donde se unieron las diferentes entidades gubernamentales para poder crear esa política verde sobre las energías renovables. Y ya tenemos, por ejemplo, la parte de hidrógeno, que ya está siendo implementada en Panamá como parte de los futuros combustibles marinos. Igualmente, podemos decirles que una de las cosas que estamos haciendo desde el MTCC o MTCC Latinoamérica, contribuyendo a estas políticas verdes, estamos lanzando próximamente un dashboard, que es un tablero digital sobre emisiones, ¿sí? En este caso, dentro del mar territorial de Panamá, donde vamos a ver al buque que entra a Panamá, cuántas emisiones está emitiendo en nuestra área de CO2, NOx y CH4, lo que tenemos como metano. Como primera parte, nuestra próxima intención es expandirlo a toda la región latinoamericana en comunicación con las diferentes autoridades marítimas para poder tener un tablero digital como si fuese un corredor marítimo. Esas son partes de políticas verdes que podemos implementar en nuestro país y en nuestra región latinoamericana.
Interesante.
Gracias, Erwin.
Does the Panama Canal has a water repository for the operation? Are there any incentive to diminish the CO2 in the Panama Canal?
Yeah, that's the answer just now, I think.
Silvia, yo creo que te toca.
Ah, sí. Quedó Silvia.
Well, yes, the Panama Canal has a green initiative, and no?
Ahora
No,
sí.
okay. Yes, the Panama Canal has a green policy initiative, and we do have a repository of water. As you know, the Gatun Lake is an artificial lake that allows the transit of vessels through the canal. It's fresh water. And we are right now in a process of doing some studies to improve that the capacity of that lake in order to keep more water, so that because in Panama it rains a lot, so we have the issue of maybe having too much rain and then having to waste that water to the sea because we cannot keep it, and to avoid flooding. But we also have the periods in which we have drought, and then we need to have enough water for the vessels to have enough draft and for the population as well. So we are, as Mr. Ureña, who spoke earlier, said, we are in the middle of developing a strategy to become carbon neutral by 2030 and to have some decarbonization by 2050. So this is the policy of the Panama Canal, and we are doing our best efforts to reduce our the carbon footprint and looking for alternatives for our own operations, I guess.
This is also for you,
Thank
but
you.
you
Thank you.
already more or less answered this one.
Yeah, both of them, I think.
Exactly.
Thank you.
I don't know who was the current speaker, but it says questions for the current speaker.
Must be me.
According to your experience, what's the percentage estimate of LNG boil off from the moment it is extracted from the well to the moment it is partially bored in the combustion chamber?
I can talk about the combustion chamber. Nowadays, it's approximately 0.08 to 0.15. Previously, it used to be 0.15 on most of the vessels, but nowadays it has come down to 0.08.
Okay. They have a question for Kijel from MAN. What is the expected performance for the methanol engines? Has it been evaluated, the transformation MaOH to H2 to fuel cell instead?
Yes.
Let me, yes, he's,
Still here.
yes. Wait.
Okay, you can hear me now?
Yes.
To be quite honest, I'm not sure. We have not made a direct comparison to fuel cells. I've been many years in you can say in this business, and it's many years before I heard about fuel cells the first time. When we look at the use for ocean-going vessels and high power, then it seems that the fuel cells is still very expensive and not the preferred solution. I think there is still some development to be done before that could compare with the high-powered engine from our side. We have 55%, as I said, of efficiency, but we haven't compared it with fuel cells as such, to be quite honest.
Thank you. I think this was for you, Salim. Somebody said, thank you for your answer. I believe in green hydrogen.
Yeah, if you go on the life cycle basis, the story will be different. Yeah, if you go on the life cycle basis and the carbon footprint, I think it will be very interesting for you to look into that, because ammonia is used to produce hydrogen, and it's highly power intensive. And then ammonia emits a nitrogen also. So please do look into the on the life cycle basis before you decide which one you want to use.
Okay, the next one is for Sylvia. What is the Panama Canal Authority doing to minimize its carbon footprint regarding its own energy generation at Miraflores power plant?
I don't think we have anybody to answer that question.
Yes, me neither. Do you know, or nobody knows? Sorry, we don't have an expert in that area.
I'll take the next.
Yes, next one. Can methanol be stored at same temperature diesel bunker fuel is stored?
Yes. The average temperature at which the methanol is stored on both the ships is about 30 degrees. The average temperature at which the methanol is stored on board the ship is about 30 degrees Celsius. So yes, it can be stored at the same temperature.
Salim, there's a lot of people asking for the presentation, if they can get it.
Yes, whoever is registered, please send, we will send it to them.
Okay, we will send it to everybody who has been registered. Is there anybody here in the room who has another question?
Or in the audience on the webinar.
Or on the audience? Yes?
Mi pregunta sería más que todo para lo que sería fabricantes de motores, ya sea Wärtsilä, ya sea MAN. Me quedo con la inquietud de que a los motores actuales que están funcionando con diésel, a los que mencionó el representante de Wärtsilä, que tienen unos kits para adaptar lo que sería diésel a metanol, quiero saber cómo es el principio de ingeniería para que estos motores no pierdan su eficiencia, no pierdan el poder, que fue lo que él mencionó, porque como bien sabemos el metanol es un combustible menos volátil y con una combustión más lenta. Entonces quiero saber cómo funcionaría ahí el proceso en lo que sería la transformación de estos motores.
Olmedo.
Sí, gracias por la pregunta. Bueno, el principio de ingeniería obviamente consiste igual que en los motores MAN en utilizar un poco del pilot diésel y bajo compresión inyectar obviamente el metanol y llegar a las presiones requeridas por el motor, ¿no? Y como les comenté en parte de la presentación, esto ya ha sido analizado hasta cierto punto de que la potencia del motor en rendimiento real no se vea afectada. Esto, la sincronización entre diésel y metanol también se hace automáticamente a través del sistema que mencioné muy rápidamente, que se llama UNIC. Y bueno, y realmente toda la magia de esto ocurre dentro del inyector, que es obviamente es más patentado en el caso de nuestros motores. Sin entrar mucho en la parte de compresión, en la cámara de combustión y todo, igual, con mucho gusto, podemos entrar en contacto después para darles más detalles de cómo puede funcionar esto. Pero básicamente todo esto es automáticamente hecho a través del sistema UNIC, ¿no? Y los motores MAN también funcionan similar en este caso.
¿Alguien más de la sala?
Bien, buenas tardes. Haré mi pregunta en inglés porque va dirigida al señor Lawrence Navy. Okay, so talking about the safe handling of methanol, I want to ask about the nitrogen. We talk a lot about nitrogen, but what is the role of the nitrogen? And maybe if you know how we produce the nitrogen on board ships, or the way that we get the nitrogen and we can use it on board.
Chell, can you take this question, please?
Who?
Chell.
Okay.
Yes, okay. You can hear me now.
Yes.
Yes.
Yes, we will have a production of nitrogen on board. The nitrogen is used as a neutral gas to purge the systems. So we have it in our ready in our fuel valve train to flush whenever it's needed and to ensure that there will not be any methanol left in the pipings on the engine itself. But it is produced on board normally.
Anyone else?
Any other question? Anybody else?
No, thank you.
I have a question. Perhaps for you, Salim. We have about 9 bunker suppliers here in Panama, bunker barges, companies. And some of them provide training to our cadets on board. How can they prepare for this? What is easier for them to do?
Well, first of all, of course, it's always a chicken and egg situation in most of the cases. But in case of Panama, the business is guaranteed because if it's a connection between the Atlantic and the Pacific. So there is hardly any risk for them because methanol is there. Methanol has arrived, and methanol is there to stay. There's Chell mentioned in his presentation, they have got orders for 100 vessels at the moment already. And then in addition to that, there were more which are in the pipeline, which he didn't mention, and the Wärtsilä didn't mention. So this Panama being a transit place, they are guaranteed the business. So they should prepare. Now, they don't have to order, sorry. They don't have to.
Sorry. No, I just want to say it, and I forgot that, sorry. But I think it's important also that we have, of course, special courses for the marine engineers when using the methanol engines, both for safety but also normal operation. Sorry, Salim.
No issues, none whatsoever. It's always because what I was saying was that they don't have to buy a new bunker barge. The easier solution is they have got a, let's say, 7,000 cubic meter vessel. They have got 10 tanks. They can allocate certain number of tanks for methanol, to carry methanol also. And methanol, like, as the best of my knowledge, and Kjell, correct me for that even if it is mixed with a little bit of diesel, it will not impact its performance or use on board the ship. Kjell?
Yeah. No, you're right. And then the beauty is that you can actually use normal tanks that you have used for fuel oil before if it's just coated correctly.
Yeah, and the ventilation system, the closed circuit monitoring for the flares.
Mhm. Yeah.
Yeah, the very few modifications are required. So they don't need to invest too much in this thing. You just have to be prepared by very minor modifications. And methanol is arrived. Methanol will be needed. So they have to be proactive,
Yeah.
not reactive. You have to be prepared. Yeah.
Thank you. Anybody else? No? Then thank you, Salim. And I think we want to thank everybody for their participation and of course, Ana Raquel and Captain Salim. And then Captain Salim is inviting you all to the cocktail outside, courtesy of Sea Commerce.
The courtesy of RQ.
And we have a little surprise for you outside, so please come and join us. Don't leave.
Yeah.
There is wine and tapas and everything you can think of, and dancing as well.
Yeah. Let me finish before we go. I would like to. The dancing was the important part.
Before leaving,
before.
I just want to thank Captain Salih because he called me and he said, I just want to do this in Panama, no charge, just because the spread of knowledge. Para los estudiantes, el capitán Salim me llama un día y me dice, Ana, quiero ir a Panamá a dar este curso, a hablar, a difundir el conocimiento. Y creo que hay que darle gracias al capitán Salim porque muy pocas personas hacen esto libre de costo y simplemente para transmitir lo que él sabe. Así que por favor quiero que le demos un aplauso.
Thank you. I would like to thank Anna, who I have known for the last 18 years. But I'm known for 18 years, but I met her also after 18 years. She responded to my call. Captain Allard, who walked the walk with me to put this thing together. And then Larry and Powell, who flew in to share their knowledge with you guys and all. And Kjell, Almeida, and Kasrat, Jason, thank you very much. And so it's Angel and Alexis and Irvin. Irvin, your presentation was fantastic. Thank you very much. And Anna, once again, thank you very much.
You.
And Captain Allard. Ciao.